Hey folks, today's topic, we are converting angles. We're looking at coterminal angles, and then we're looking at complementary and supplementary angles. So lots of little stuff that I don't think we want to do them all individually. We can just kind of throw a bunch of these little topics together in one lesson. So how do we convert? We talked last time about radians, and we talked about these things called degrees. So degrees we're used to, that's a rotation around the unit circle, where radians are a measure of length around the circumference of the unit circle. And how do we convert between these two things? So hopefully you've done this in your science classes. I think especially chemistry has its own whole section called stoichiometry that changes between, I think I'm using the right stuff there. Anyway, all right, so convert the given angles to either degrees or radians. So I'm going to multiply by a fraction. This is how I always think about things when it comes to converting. I always want to multiply by a fraction. I want to cancel out the unit that I'm in, and I want to convert it into the new unit. So think about it this way. This is already a fraction. I can make anything into a fraction by putting it over 1. And then I've got this relationship between degrees and radians. And if you remember this, if you want to put it on your unit circle, feel free. The only thing you need to do is you need to find one relationship between radians and degrees. Whichever one you want, you could use. I always use the simplest one, which is pi radians is equal to 180 degrees. I mean, you could use 2 pi and 360, it'd get you the same thing, but pi and 180 are the same thing. So when I do a conversion, if I'm in degrees, I'm going to put the 180 either on the top or bottom of this fraction. I'm going to put the pi radians on the top or bottom of the fraction. And you make the choice based on the units that you're in and the units that you want to cancel. So I'm in degrees. I want to end up in radians. That means I have to put the degrees at the bottom. Why do we have to put it down there? Well, think about it. If I have degrees divided by degrees, what's going to happen? Those are going to cancel. Degrees divided by degrees would cancel out. Now, I can't put 180 on the bottom without putting 180 degrees on the top. Now, if I write 180, I'm still going to be in degrees. So what we're going to do instead is we're going to write something that's equivalent to 180 degrees, which is pi. Now, I'm not going to write the RAD of radians. You can if you want to. I just remember if I don't write the degree symbol, it's automatically in radians. Not because it has a pi. I could take 3 pi over 7, and if I write a degree symbol right there, all of a sudden that's in degrees. If I took 204 and I erased the degree symbol, that's in radians, at least in this class. So then we would get, okay, we've got two fractions. We multiply straight across with fractions. 36 pi over 180. And then we would try to reduce this thing. 36 and 180 are both divisible by at least 6, right? So 6 goes into there 6 times. 6 goes into there 30 times. 6 and 30 are both reducible by 6 again, so I get 1 and I get 5, which leaves me with a 1 and a pi on the top and a 5 on the bottom. So 36 degrees is equivalent to pi over 5. Now let's go the other direction. Let's take our measurement around the unit circle. I'm always going to multiply by a fraction. This time it's already in radians. And how do we know that? Because it doesn't have a degree symbol. Not because it has a pi, because it doesn't have a degree symbol. So I've got to put degrees and radians somewhere. This is already in radians, so I want the radians to cancel out. So I'm going to put the pi on the bottom this time, which leaves me with the 180 in the numerator. What's going to happen to those pi's? They gone. And from here, I don't try to clean it up nice and neat like this. If you use your calculator on this, you're going to get a decimal because pi is 3.14, blah, 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 blah. But our pi is canceled out over here, so I'm just going to use my calc. 5 times 180, 5 times 180, and then divide by 8. And you're allowed to have a decimal when it comes to degrees. Radians, we like to keep the pi value in there if possible. All right, let's have you pause here and try to do the next two on your own. So hopefully you got 77.14 degrees and 17 pi over 15. All right, next up, in which quadrant does the given angle lie? So let's do a quick review on how quadrants work. Let's actually put it right on our unit circle. So grab your unit circle. We're going to label our quadrants. We call this quadrant 1. And then it counts counterclockwise. This is quadrant 2. This is quadrant 3. This is quadrant 4. So that's a quick review of how quadrants work. Remember, this unit circle is in the coordinate plane. So this is still the x-axis and this is still the y-axis. We just happen to draw a circle of unit radius 1 in that coordinate plane. So going back to our problem here. All right, let's make a sketch. Where are we going to end up in the unit circle if we do negative 7 pi over 4? So we talked about this last time. First, decide what you're counting by. I'm counting by pi over 4s. Pi over 4 is the same as how many degrees? Well, I always think about pi as being 180. 180 divided by 4 gives me a 45. So I'm counting 7 gaps of 45, but I'm counting them in the negative direction. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. 1 to the origin, 1 to the x-axis. Now, they didn't say that we had to label the reference angle here. All we're trying to do is figure out what quadrant we're in, and I can tell what quadrant we're in just by looking. So the answer to this is in quadrant 1. Negative 431 degrees. All right, I love radians. I used to love degrees when I was a student, and now that I understand how radians work, they're much easier to calculate. I need my calculator to figure this out. So, all right, so negative 431. I want to go a rotation of 360, but if I subtract 360, that number would just be getting bigger and bigger. So I'm going to add 360, so negative 71. So negative 71 would be this direction, but 71 is less than 90. So I'm going to estimate right there, close enough. Draw my triangle, 1 to the origin, 1 to the x-axis. That's quadrant 1, 2, 3. That's quadrant 4. Pause, you try the next two. Should have got quadrant 3 for part C and quadrant 2 for part D. Now here's our next topic where I talked about up here. We're going to do converting coterminal. This is what I mean by coterminal. Find two angles, one positive and one negative, that are coterminal with the given angle. So let's do a quick review. I would like you to count around to 7 pi over 3. All right, let's see how you did. 7 pi over 3 means I'm counting by 60s. I'm counting 7 gaps of 60. 1, 2, 3, 4, 5, 6, 7. Okay, now leave your finger there. And I'd also like you to count around to negative 5 pi over 3. So I'm counting by gaps of 60 in the negative direction, but I'm going 5 of them. 1, 2, 3, 4, negative 5 pi over 3. So wait a minute, negative 5 pi over 3, 7 pi over 3, and pi over 3 all took me to the same location on the unit circle. That's what coterminal means. So I'm going to encourage you to pause here and write a little note to yourself. What does coterminal mean? I kind of think about it as different rotations or different angles that take me to the same spot. So pause there and discuss what is coterminal. Write a little note. Note to self about coterminal, what it means. So we have been asked to not just find any random coterminal angles, we need to find one positive and one negative angle that's coterminal with the given angle. Now, degrees are super easy. So 150 degrees. If I wanted to go another lap from 150 degrees around the unit circle, how many degrees would I add to go all the way around? 360, right? One full lap is 360. So 150 plus 360 would give me another angle that is coterminal with 150. But if I add 360 again, I would just keep getting bigger and bigger numbers. So I want to add 360, and then I also want to subtract 360. When I do 150 subtract 360, that's going to give me my negative value. So if we're looking at this one, I'm starting off at 150 degrees. I want to find the positive by adding 360 degrees. So that's 11 plus another one, so that's 510. 510 degrees and 150 degrees are coterminal. Now I need a negative, so I'm going to take that same gap and I'm going to subtract 360 degrees. 150 take away 360 is negative 210 degrees. So if you rotate it around the unit circle 510 degrees or 150 degrees or negative 210 degrees, every time you would end up at the exact same place. Let's do it in terms of radians. Now you can add, you know how we added 360 degrees? So what would we add if we wanted to do that same rotation in radians? We would add 2 pi. But it's much tougher to figure out adding 2 pi, I think. Maybe it's not. Maybe if you want to write 2 pi there, get common denominators and go for it. I just think it's easier to count around the unit circle using our techniques from last lesson to figure out where 5 pi over 3 would be another positive and then another negative angle. So I'm going to start at 5 pi over 3. That's the number 5. Now I'm going to just count around to 5 pi over 3 again. Now remember, this is 5, not 1. This is 5, not 0. This is 5. So I'm starting at 5. Then I go to 6, then 7, then 8, then 9, then 10, then 11. So 11 pi over 3 is coterminal with 5 pi over 3. But we're supposed to find one positive and one negative. So I'm going to go back to 5 pi over 3. Remember, you're starting at 5, and then you're going to count backwards. So this is 5. Now I'm going to count backwards to 4, 3, 2, 1, 0, negative 1. So 11 pi over 3 or negative 1 pi over 3 all take us to the same place. Those are all what we call coterminal. I'm going to encourage you to pause here. You try to do the next one on your own. All right, 7 pi over 6. Let's see if we can do both of them on the paper and then flip back. 7 pi over 6. I first got to count by pi over 6, so that's 30s, and I got to count 7 of them. 1, 2, 3, 4, 5, 6. There's 7 pi over 6. Keep going, so that's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 pi over 6. That's the same as 7 pi over 6. Or I can start at 7 and count backwards. 7, 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5. So 19 pi over 6 or negative 5 pi over 6 are coterminal with 7 pi over 6. All right, last but not least, we're going to talk about, we've talked about converting, we talked about coterminal, we've talked about, we haven't, complementary and supplementary. Okay, complementary angles and supplementary. Most of you remember at least looking at these back in your geometry days. Let's do a quick little note reminder. And if you want to put this on your unit circle, I'm fine with that. Actually, let's put it right on our unit circle. Note, complementary has 1p. Supplementary has 2p. What I mean by that is in the word complementary, there is one letter P. In the word supplementary, there is two letter P's. And that represents, each letter P represents a 90 degree. That's how somebody, I don't remember who it was, somebody told me that last year, and I thought it's a great way to remember. So this has one P in it, which means that the two angles add up to 190 degrees. This has two P's, which means it has 290 degrees. So a 90 and a 90 add up to 180 degrees. Now, if you want to remember it that way, it's fine. If you just want to look back. And so complementary means 90 degrees. Supplementary means 180 degrees. Complementary has 1p, 190. Supplementary has 2p's, which means 290 degrees. So in other words, 180 degrees. So pretty straightforward here. Find the complement and supplement of the given angle. Now, this is my note. I'm going to grade this. You must be in the same unit as the given angle. So if I give you an angle in degrees, your complement and supplement must also be in degrees. If I give you in radians, you also have to be in radians. So let's start off with complementary. So complementary means two angles that add up to 90. Well, if one of them is 37, how would you figure out the other one? I would start with 90 and then subtract off 37 degrees. 90 subtract 37 degrees ends up being 53 degrees. Done. Supplementary. Supplementary adds up to 180. So if I wanted to figure out who's the supplement of 37 degrees, I would start off at 180, and then I would subtract 37 degrees. 180 subtract 37 is 143. So complementary and supplementary are pretty easy when it comes to degrees. When it comes to radians, it's a little bit sneakier. It's a little bit more complicated. So let's talk about that. So I'm going to do the same process, but I'm going to do it from the perspective of radians. So complementary. Angles that add up to 90 are complementary, but 90 degrees is in degrees. We want to think about it in terms of radians. So who's the same as 90 in the world of radians? Pi over 2. Now, just like over here, we subtracted the given angle, I'm going to subtract the given angle here. Now, this is why this is more complicated, because we have pi over 2 and 2 pi over 5. Those don't have common denominators. So I'm going to be lazy, and I'm just going to write the common denominators right on top. So least common multiple would be 10. So this needs a 5, and that would make this a 10. This needs a 2, so that would make that a 4, and this would be a 10. So 5 pi over 10, take away 4 pi over 10, ends up being 1 pi over 10. Supplementary, same idea as degrees. 180 minus, but 180 is not going to cut it because we're in radian world. So who's the same as 180 in radians? would just be pi. And we need to subtract off our given angle. Now we have two numbers. If you're ever going to try to subtract a fraction, the other thing needs to be a fraction, so I'm going to make that a fraction first. Then we need common denoms. Least common multiple of 1 and 5 is 5. So 5 pi over 5, take away 2 pi over 5, ends up being 3 pi over 5. All right, lots of little tidbits in there, but stuff that I think that's important when we think about trig and how those angles fit together in the unit circle.